This question is about locus. So it asks us to find the equation of the locus. The point here, A, is tan 6. Let P be a moving point in the rectangular coordinates such that P is equidistant from A and the x-axis. From there, you can see that it is a point and the x-axis. Means that the locus should be a parabola. A. First, we need to let P be xy. And xy is not a constant. By applying the Pythagoras theorem, here, because it is the distance from A and this is the distance from Y. Then, after squaring both sides, we'll get this. X squared minus 20x minus 12y plus 136 equals 0. For part B, the locus intersects y-axis at C. Denote the origin by O. Someone claims that the distance from C to OA exceeds 10. First, we need to find the coordinates of C. As coordinates, this one intersect y-axis. It is the y-intercept. So the x-coordinates must be 0. So we just need to substitute x equals to 0 into the locus. Then, when calculate the remaining, y is equals to 34/3. After that, I prefer to draw a graph. Here, let me draw it bigger so it is more easier to see. This point here is A. This point here is C. OA is right there. This is C, which is perpendicular. So, to prove that whether this distance right here is bigger than 10 or less than 10, we first need to find this. We need to use the triangle here. So, we know that this one is 34/3. We need to find this. Oh my god. Sorry. We will find this length right here. Let me redraw a graph. We need to find OA. What is the length of OA? Simply this. 10 squared plus 6 square root. Then this one we know is 34 over 3. This length here. And this length here, we know as well. Because we know that this is 34 over 3. And this one, OA. So, we can find this as well. 34. By using the distance formula, 34 over 3 minus 6 square plus 10 square. Square root of it will be equal to AC. Wait, let me calculate. So, AC is equals to 34 over 3. So we can know that this is an isosceles triangle. And by a property of isosceles triangle, we know that this 2 is equals as well. So, as we found that OA is equal to root 136, the midpoint here, this length right here, will be equals to root 136 divided by 2. And by applying Pythagoras theorem, we can find that the distance will be equal to this square minus this square root of it. Then we can calculate the answer. It is equals to 9.72, which is less than 10. The claim is incorrect.